Too many features? Too much complexity? That's where PCA comes in. Imagine reducing a dataset's dimensions while keeping its core insights intact. It's like decluttering your data without losing valuable information. In this video, we'll break down PCA, apply it to a real dataset, and compare the dimensions before and after. Get ready to see how PCA makes high-dimensional data more manageable and useful. Welcome to day 22 of the 30 Days of Machine Learning series. If you're just joining, don't worry. You can click right here to access the full playlist and catch up on every step of the journey so far. And hey, make sure to hit that subscribe button so the next video in this series drives straight into your feed. First, let's bring in the essentials. Pandas for data handling, NumPy for calculations, Matplotlib and Seaborn to make our visuals pop. Reading the CSV into a data frame, and with head, we get a quick sneak peek at the first few rows. Shape reveals the number of rows and columns, while columns lists all available features we can work with. Cleaning up unnecessary columns, dropping identifiers and non-essential features to keep only what matters. A quick dot head ensures everything looks right. Identifying missing values to avoid issues later. Age gets the median value for consistency. While embarked takes the most common entry to maintain dataset integrity. Quick fixes, big impact. Converting categorical data into numbers. Machine learning models work with numbers, not text, so we use label encoder to transform sex and embarked. This assigns unique numeric labels, making the data model-friendly while preserving meaning. A small step, but crucial for making our dataset ready for machine learning algorithms. Now we split the data. X holds the features, and Y is our target variable, whether passengers survived or not. Scaling the features. Using standard scaler, we standardize X, so all features have a mean of 0 and a standard deviation of 1, making the model's learning process smoother and faster. Visualizing relationships between features. A pair plot shows how different features interact, with color highlighting survival, giving us key insights into patterns. Now let's explore feature correlations. This heat map shows how each feature is related to the others. The color intensity highlights strong relationships, helping us understand which features might influence survival the most. Let's check the distributions. For each feature like age, fair, SIBSP, and parch, we plot histograms with kernel density estimates, helping us see how they vary between survivors and non-survivors. It's all about spotting trends. Here's a box plot showing the distribution of age by survival status. It helps us spot age-related trends and differences between those who survived and those who didn't. Let's apply PCA. By reducing the dimensions to two components, we simplify the data while retaining its essential patterns, making it easier to visualize and analyze. Here we check the impact of PCA. The explained variance ratio shows how much information each component retains. We also compare the original and reduced dataset shapes to see the dimensionality reduction in action. This scatter plot shows the two-dimensional projection of our data after PCA transformation. We've reduced the complexity of the dataset, using the first two principal components, while color-coding the points by survival status. The plot reveals how PCA helps us visualize the separation between survivors and non-survivors. It's amazing how much clarity dimensionality reduction brings, making it easier to spot patterns that were otherwise buried in higher dimensions. Here's a scatter plot of the original data, using the first two features. By color coding by survival status, we can visually compare how the raw data stacks up before PCA reduction. Let's compare. Here are the first 5 rows of the data before and after PCA, showing the original scaled values versus the reduced 2D representation. Now, we split the data into training and testing sets. 80% of the data is used for training, while 20% is reserved for testing, ensuring we can evaluate model performance effectively. We're training a random forest classifier now. By fitting it on our training data, it learns to predict survival based on the patterns we uncovered through PCA and feature transformations. Now, we make predictions using the test set. The accuracy score tells us how well the model performs, how often it correctly predicted survival. Let's see how our random forest did. And that's a wrap for PCA. We've transformed our data, visualized it, and built a predictive model. But hold on, the journey isn't over. Next up, we'll dive into singular value decomposition, SVD, another powerful technique for dimensionality reduction. Click on the screen to continue and unlock more insights. See you there.